All right, looks good. I don't know what happened before. So a positive upward slope. Oh, let me do that. Positive upward slope. So if you have a slope that's like this, going up and positive, what does that mean?
It's going away.
You got moving away from the sensor. So motion is away from the sensor. Then number two, negative slope. So down like this. It could be steep. It could be not steep. That means moving toward the sensor. Number three, the steepness. So you could have a slope this steep, or you could have a bigger slope or steeper slope. What does the steepness tell you? How fast? Steepness is speed. Steeper is faster. And it doesn't matter whether we're talking about a negative slope or a positive slope, the steeper slope is going to be faster. A constant or straight line. So you can have a slope like this, and you can have a curve. The fact that it's not curved tells you what? What is the thing doing?
There's no acceleration.
Yeah, no acceleration. It's moving at a constant speed or a constant velocity. Because if the speed is the steepness, this is equal steepness the whole time. This is getting more steep, so it's not the same speed the whole time. A smoothly curving line like this means the steepness or the speed is changing. It's either positively or negatively accelerating. Number six, sketch a negative slope becoming less steep. And what does that, like, what would a thing be doing if its graph were a negative slope becoming less steep? What would you have to do near the sensor to make a graph like that?
You start far away and you slow down as you get closer.
So you move toward the sensor and get slower. So here's an example. Got a steep negative slope. I've still got a negative slope, but it's less and less steep. By the time I get to here, there's pretty much no slope. So this is moving toward the sensor. Distance is decreasing, and I'm slowing down. Negative slope getting steeper. It could start out like this, but it would need to plunge downward. And if you're doing that, you're still moving toward the sensor, but what are you doing differently than if you had that other slope? When the slope's getting steeper, what are you doing? Oh, speeding up. Positive slope becoming less steep. So which way are you going? Toward the sensor or away from the sensor? Away from the sensor, and getting faster or slower? Slower. So this would look like that, moving away, slowing down. Then the last one, just sort of the reverse of that, positive and getting steeper. So you're still moving away from the sensor, distance is still growing, but you're doing it faster. You're moving away and speeding up. So if that all makes sense, what I'm about to go over should make sense, but it's an extra level of challenge thrown on. So flip to page 9. These are the practices I'm going to take you through, and then your homework is just to do page 10. My website right now says to do page 10 and 11, but just page 10. And I want you to make a change at the bottom of page 10. All the velocity graphs on this assignment should have sharp corners, because it says in the beginning, I added this year, just to keep things easy, we're going to assume acceleration is constant. So change this graph so that it just goes straight like this and then straight over, and there's not that smooth corner. So you get an abrupt change in velocity. And while we're at it, even though you don't have to do this tonight or tomorrow night or whenever it is, flip to the next page, page 11, and do the same thing to this velocity graph.
Should we do it with the distance graph?
No, those can be curved. So the acceleration graphs will not be curved, the velocity graphs won't be curved, but the distance ones, just like the ones you just did, those could be curved. And that should be curved. So the goal here, going back to page 9, is to take 3 graphs and represent the same motion 3 different ways, beginning with a starting graph. So in this case, we're beginning with a graph just like the ones you did. This could be somebody walking, they're going toward the sensor, they're going fast, and they're slowing down. Then we have to do a graph of velocity, and then we have to do a graph of acceleration. So I've got a little fill in the blank question for you. Blank equals the slope of the position versus time graph. The slope of the position versus time graph tells us what? If you calculated that, you would be calculating something. Slope is rise over run. Slope tells you basically the rate of change. As time goes by, like with every second, this tells us that the position goes from here to there in this amount of time. So that's a pretty rapid change in position. But between here and here, in this time, the position changes this much. And by the time we get to here, the position is going from there to just a little bit lower over a long time period. So position's changing really fast here, position's changing slower there. I'm talking about slope when I'm talking about the ratio of change in position to change in time. So what's the word for what I've been beating around the bush about?
Average velocity.
It's velocity. So the slope of this gives you velocity at any given time. So velocity is the slope of a position versus time graph. And while I'm at it, if you have a velocity graph and you take the slope of that to show how velocity is changing, guess what that gives us? So something equals the slope of a velocity graph. What is the thing? Acceleration. So acceleration. So that's the key. If you know that, you can do these. There's more to it. There are more things that I would recommend thinking about as you do this, but that's the gist of it. So what I'm going to do is follow these rules. I'm going to work left to right. We're going to take this graph and use that to draw this one and draw this one. Here, we're going to have to go the other way, which is trickier. Left to right's a little bit easier. So to draw this, all I have to do is look at these moments of time in time, go over here and measure these slopes. I don't know what they really are because there aren't any numbers, but I can tell whether they're positive or negative. I can tell whether they're steep or not steep. So in the beginning, is this positive or negative, this slope? Negative. Is it a steep slope or not steep slope? Steep. So would this be somebody going fast or slow? Fast, but negatively. So this is going to start way down here. And just jumping ahead to right there, what's the slope here? 0. So if you're like doing this, how fast are you moving? If you were doing this, you'd walk toward the sensor and get slower and slower and slower. How fast would you be going when this is a straight horizontal line with no slope? You wouldn't be going. So what's your velocity then? 0. So basically, the velocity versus time graph is like that. How do I know it's not curved? It's because I told you to assume that acceleration is constant. So what we've got here is some negative velocity. I'm just going to make up a number. I'm going to say this is negative 10 meters per second squared. Or sorry, meters per second. So what happened there? So if that's negative 10, for every second that goes by, we're adding the same velocity to get to here. The slope is the same. So because acceleration is constant, you're not going to have to worry about curves on the velocity graph. Okay, so if these numbers give us the slopes of this, negative number, negative slope, 0, 0 slope, then these slopes give us these numbers. So what's the slope of this line right here? Is it positive, negative, or 0? Positive. Positive. How about here? Positive, negative, or 0? Positive. And is it increasing, decreasing, or staying the same positive slope? Same positive slope. So acceleration is like that. Exactly how high to make your line, we don't know because there are no numbers on this, but the acceleration is constant. We're adding the same number of meters per second every second. So it's not too hard when you go from left to right. And we'll be talking about thinking through this in different ways in the future, but for now, just use these as your guiding principles. So let's start with velocity and go to acceleration, because I said that was easier. But this has got to change, and what I like to do when we have a change in here is to do a little dotted line. This is representing the moment in time where what this object is doing here is different from what it's doing there. And I'm going to put that dotted line in my acceleration graph and also in the position graph. So acceleration, these values are going to be slopes of this. So what is the slope of this right there in the beginning?
0.
The number is 0, but the slope is
Negative.
positive or negative? Negative. And how about here?
Negative.
Negative. Negative. Is the slope changing? No. So what this means is that the slope of this, that's the acceleration. And the acceleration is just going to be some negative number. And since I've told you acceleration's constant, we're always going to have flat lines on acceleration. It's either going to be a negative number down here or a positive number, or it's going to be 0. So now, take a look at this. What's happening to the slope?
0.
It's 0, and it's still 0, and it's still 0, so the acceleration is
0.
0. And step back and see if this makes sense. If your velocity is -3 and -3 and -3 and -3, are you accelerating? No, so your acceleration is 0. And if your velocity is 0, then -1, -2, -3, are you accelerating?
Yes.
Yeah, you're accelerating negatively. Now this is the hard way to go. So the slope of what we're about to draw gives us these numbers. So I can just take a number here and then make sure I draw something over here with the slope. When you go right to left, you don't know where to start. You could start anywhere and it's equally valid. Like, how fast is this? How fast is it? If I wanted to go that fast, what would I do? Not move. That's 0. So it's right on the axis. That's 0. So over here, I just need to draw somebody who's not moving. Do I know how close they are to the sensor? No, I could put them close. I could put them far away. And I'm going to kind of I want to make this look good. So 0, negative. Okay. I know how this is going to turn out. So I'm going to start up here just because I know how this is going to end. So the slope right in the beginning needs to be 0. So that is flat. But it's not going to be flat for very long. So that's all I'm going to do. Now, this is, say, -1, -2, -3, -4. That means the slope of this is becoming more negative. So is this going to go straight out? Is it going to go up or go down? Down. And is it going to be the same steepness?
No.
No, because it's going to be a bigger and bigger and bigger negative slope. So it's going to look like this. So I have 0 slope in the beginning, negative slope, more negative slope, more negative slope until I get to there. So now, what are the numbers doing for velocity here? They're staying the same. So they're negative. Same negative number as I ended up on right there. So that means the slope in this area has to be the same negative slope that I just stopped on. So I'm going to turn my paper this way because it's easier for me to do this, and then draw this straight. So straight line there, downward curve here. And if you want to go in reverse to check it, that's probably a good idea. The 0 slope, velocity is 0. Slope starts to become more and more and more negative, velocity is more and more negative. The slope is constant and negative, velocity is constant and negative. This one's the hardest one because we've got to go through like 2 different places. Oh, by the way, I could have drawn this, like I could have done a more gradual curve, and I could have started it from there and then straight. Or I could have made it really sharp and then straight. So there are a lot of equally valid ways to do this one. All right.
How did you know that the line would curve the way it did, not the other way?
This, because of what velocity did. So velocity starts at 0, so I've got to make it flat, 0 slope. And then it's negative. So negative slope means downhill, so I've got to start it curving down. And since these are bigger, like this is a -1 slope, which might look like this. This might be a -2 slope, which is like that. This is -3 slope, which is even steeper. So this just means that has to get steeper every time. But then this is the same negative slope, so I keep the same negative slope. So these numbers, what's this? Oh, stop that. The numbers are positive, negative, or 0?
Positive.
Increasing or decreasing or staying the same?
Staying the same.
So the slopes here need to be positive and the same every time. I just need to do, I'm going to do a dotted line. And before the dotted line, I'm going to do a slope that's positive and the same. So I could start wherever I want. I'll just do it like that. So the slope of this is positive, 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 and the same. And that's the same. So if I drew that, what's this part going to look like?
Negative on the same.
It's going to be symmetric. It's going to be like this because these numbers are the same negative numbers, so now I need a negative slope that's the same. And this should be symmetric because it looks like this is about as big as that. So this slope should be about as positive as this slope is negative. And now the last one. This one's really tricky. To begin with, oh, you know what? I'm going to make this a little easier on myself. So if you drew it like I did it before, you might want to draw another one, and let's use this one. Why is this easier to draw than what I started with? Does anybody know?
Starts and ends at 0.
Starts at 0 and ends at 0. So the fact that this starts at 0 means what needs to be 0 over here in the beginning? The slope. So this needs to start flat, and then at the end I'm going to be flat again. So I'm going to start flat because this is 0, and then through this area, what's going to happen to the slope? I just look at this.
It's going to be increasing.
Increasing in positive or increasing in negative?
Positive.
Yeah, so I've got positive numbers here. We've got positive velocities, and they're getting bigger. So the slope is going to go from 0 to a bigger and bigger and bigger positive slope. I wish I'd started it lower down. In fact, I'm just going to redo it and do it lower down because I could, like that. So what's going to happen? These numbers are they positive or negative numbers? Positive. Are they getting bigger or smaller? Smaller. So I start out with a positive slope, and it's always staying positive until the end, and it gets down to 0. So it looks like that. So 0 slope in the beginning, 0 velocity. Steepest slope right here is positive slope. Big, fast, positive velocity. 0 slope at the end, 0 velocity. So your homework is to do just page 10. So you're given this one, do the other two. Given that one, do the other two. So 4 sets of graphs to do. Take a look at my solutions, and remember that on ones where you go right to left, like this one, there are multiple ways you can draw that based on these velocities. Same with this one, and same with this one. When you go to the right, there's really just one basic way to do it. Grab your phones, wait for the bell, that's it. Remember, if you want to be thinking about rockets, we'll probably start working on rockets next class. If